All right, for problem number 2, we were told Andrew wants to cover the top of a toy ramp, shown in the figure below, with a piece of smooth wood. So if we imagine this is a toy ramp here, it has a height of 3 centimeters, a length of 10 centimeters, and then this toy ramp here going up. That's where the piece of wood's going to be going. Really, the key here was to recognize they're really just asking us what is the length of this side of the hypotenuse, or the right triangle's longest side that we see here that's not known yet. So if you see this right triangle in this real world 3D figure, and we know two sides, the height is 3, the length is 10 centimeters, those are both going to be the legs. We're going to see and label that here. 3 could be called A, 10 could be called B, and the key is that the side we don't know yet is C. Again, this is one where we know the two short sides, the legs, and we're going to be asked to find C, the longer side, the hypotenuse. So in that situation, we take our formula, A squared plus B squared equals C squared. And we know that A could be replaced by 3, B could be replaced by 10, so this becomes 3 squared plus 10 squared equals C squared. Order of operations takes over now. It's just numbers on the left side of the expressions. So 3 squared is 9. Terrible 9. 10 squared is 100. And when we add those together, we get 109. That's equal to C squared. The key here, how are we going to get C squared simplified down to just C? What is the inverse operation for squaring something? That's to take the square root. So we square root both sides. Whatever the square root of 109 is, that's going to be what C is equal to, because C squared was going to give us 109. So again, I'm going to have to use a calculator to find square roots. I know the square root of 100 would have been 10, so our answer should be a little bit bigger than 10. When we look at square root of 109, we see 10.4403. 10.4403. So they asked for the approximate length of the piece of wood in centimeters. And now you're going to see when you come to this problem, I'm going to say to the nearest hundredth. So you're going to take a look, where is the nearest hundredth? That's 2 decimal places. So when we're looking on our whiteboard, that's the second 4 that appears. So if we're rounding to the nearest hundredth, we could say the answer is 10.44 centimeters. One of the big keys is to look and see, does that make sense? Sure, if this is 10 centimeters, this is just a little longer because it's going up in addition to across. So 10.44 seems reasonable there.